What's up, guys? In this video we're going to look at two features that are very useful when we're talking about the routing process. We know that by default the FortiGate, it performs the routing process by looking at the destination IP, and it tries to find out, okay, what is the next hop available to reach this destination IP, and what is the interface that I can use to reach that next hop. Okay, that's the routing decision process. And in some scenarios we might want to tweak this routing decision process, and we're going to see this in a moment. But we're going to talk about ECMP and PBR. And ECMP stands for Equal Cost Multipath. And this feature allows the firewall to use all available paths towards the same destination. If we look at topology, we have firewall 1 connected to firewall 2 and firewall 3. And firewall 2 and firewall 3 are acting as the gateway for firewall 1 to access the internet. And for demo, we're just going to create a loopback IP behind firewall 2 and firewall 3 so that we can test reachability from firewall 1 or from the networks inside or behind firewall 1. And in this case, we have the network assigned to PC1, kind of the IT department, and the network assigned to finance department. Now, in the normal routing process, firewall 1 will have a default route installed in its routing table pointing towards firewall 2 and firewall 3. And it's going to load balance the traffic between PC1 and PC2 based on the source IP. So there are different algorithms that we can configure on firewall 1 to dictate which interface to use. We can adjust to use like the weight on the interface, how many sessions are being used on the interface, or even to select the traffic based not only on the source but also on the destination IP. And we're going to see this in a moment. The other feature we're going to cover is PBR, or policy-based routing. As I mentioned before, the routing process consists on looking at the destination IP, looking who's the next hops to get to this destination IP, and which interface I should use to reach the next hop. Now with PBR, we can influence this routing process by saying things like, we want PC2 to use the firewall 3 whenever it tries to use telnet, but if it's trying to use HTTP, it should use the path via firewall 2. So we can create policies that will influence the way the firewall will route the packet. Another thing that's worth to mention in regards to ECMP is that whenever we have two or more links toward the same destination, we can have a health monitor, kind of to monitor the link between one of the firewalls, let's say for instance the link between firewall 1 and firewall 2. And if that link becomes unavailable, we want to dynamically firewall 1 choose the next best available link on its routing table. Now let's see these in practice. Looking at firewall 1, we see the interfaces connecting to firewall 2, firewall 3, and subnets assigned to IT department and the finance department. If we look at the routing table, so dashboard, network, so we only have the directly connected interfaces. Okay, at this moment we shouldn't be able to reach the IP 8888. So we're going to add two static routes, one that use firewall 2 as the next hop and the other one using firewall 3 as the next hop. So we go to network, static routes, we're going to create a new one. So that's going to be the default, and we're going to select the gateway to be the interface connecting to firewall 2, and the gateway address will be 10.101.101.2, and we're going to leave the administrative distance as 10, and we're going to save this. We're going to clone these static routes, and we're going to say that the interface will be port 2 and the IP will be 192.192.2. That's it. Now let's save this. If you look at the firewall 1 routing table using the CLI, get router info routing table, we see that we have both static route installed in the routing table, and by default the routing process will load share the traffic based on the source IP. So let's see if we can reach the IP 8888, and it's successful, and we can test which interface or which firewall we are arriving on, and we see that we're using firewall 1 for that matter. Okay, as I mentioned earlier, if something happens on the firewall 2 or firewall 3 interface, firewall 1 won't have visibility to this failure, and it will continue to forward the packets towards firewall 2 or firewall 3. So let's see this in action. Actually, let me disable the interface connecting to firewall 1 and firewall 2 and see the difference on the routing table. Info routing table, we see that from firewall 1 perspective the link's still available, right? And this is dangerous. We can have a black hole, which means firewall 1 will choose a path that might not be actually available, and we can see that's the result. So we want to use a mechanism to validate whether the link is available or not, and that's where link health monitor comes in the picture. I'm going to enable firewall 2 interface again, going back to firewall 1, and we're going to configure system link monitor, and we're going to name it mon firewall 2, and we want to set the source interface to be port 1. We also want to set the server, the IP we want to monitor, to be 8888, and the protocol to be ping. We also are going to set the gateway IP to be 10.101.101.102. Okay, I believe everything is in place. Next. Okay, now we're going to assign this monitor to the interface. So config system interface, edit port 1, and we're going to set the fail detect to enable. Next and next. Okay, so let's take a look at the routing table again. So we can see we still have both interfaces. If we try to ping 8888, it's working. So now let's disable the interface again on firewall 2. Okay, it's down. So, and if we look at the routing table again, now we only have the default route via firewall 3. But this is very helpful in scenarios either virtually or physically, where the firewalls are not directly connected, or there is no way for them to be informed of link failure. So link health monitor is very helpful in this situation. So we're going to bring the interface back again. So set status to enable, and we can see that the static route was added again on the routing table. So that's ECMP in its essence. Now, when we combine this with PBR, it gives us a lot of flexibility. So as I said, we want to force the traffic from PC1 to use both links, but we also want to look at the traffic coming from PC2, and if it's telnet, just to use the link via firewall 3, but for any other type of traffic, it can fall back to the default routing process. So let's see if PC1 and PC2 are able to reach the IP 8888 before we make any change. Let me confirm the IP. So this is 110, this is the IT department PC. So if we try to ping 8888, It's working. Now which firewall is replying? So we can see is firewall 2. Okay. Now we're going to do the same test on PC2. Let's check the IP. So this is 210. So if we try to ping 8888, and let's try to telnet, and we are using firewall 2 as well. Okay. So going to log out. Now let's disable the interface on the firewall 2 to see if we're going to use firewall 3 as well. Now let's jump to firewall 2, disable the interface. Now we should only have one default route on firewall 1 routing table. If we make the same test again, so now we are using firewall 3, that's expected. Okay, and the same will be true for PC2. Now back to firewall 2, we're going to enable the interface. Okay, and we come back to FortiGate firewall 1. Now if we look at the routing table, okay, everything is as expected. Now we're going to create a route policy or PBR to force the traffic, the telnet traffic from PC2 to only use firewall 3. We can use the CLI or the GUI for this matter. So if we close this and we go to policy routes, we're going to create a new one. So we select the incoming interface to be 192.168.2. That's the finance department interface. The source address will be 192.168.20, and we don't care about the destination. We want to select the protocol to be TCP and the destination port to be 23. So we're going to set the outgoing interface to be port 2. Okay, and the gateway will be 10.102.102.2. Okay, we're going to save this, and we have our policy route. If we go back to PC1, let's see how is this going to be affected. So here on PC1, if we telnet, we're still using firewall 2. Now if we do the same on PC2, we're going to telnet, and we are falling on firewall 3. Okay, and that's what we want, right? If you go back to firewall 1 and look at the routing table, get router info routing table. Oh, we see that nothing was changed in the routing table, but we are affecting the way the firewall is routing the traffic for certain protocols. And we can do this for certain applications or sites according to the business requirements. So this is it, guys, ECMP with PBR. I hope you enjoyed, and I hope to see you in the next one.